There you go.
All right, so there we go. So here's our atmospheric makeup. So we've got a lot of nitrogen, we've got some oxygen, and then we've got a lot of miscellaneous. We've got some carbon monoxide, some oxides of nitrogen, salt. Click. Next screen, Scott. All right, so we're going to add to that one part of hydrocarbon or fuel. All right. So Scott, next screen. When we talk about parts and stoichiometry or a balanced mixture, are these parts by volume or are these by weight? What do you guys think? Are we using volume or are we using weight?
Volume.
Volume? Yeah, we're actually using weight for this, guys.
Okay.
Yeah, we're gonna use weight. So you guys have all been here at the CAT. Imagine 150 classrooms is about 1 quart. If we take the weight of those 150 classrooms of air, it's about the equivalent of 1 quart of gasoline. All right, so we're doing this by weight. All right, Scott, next. So what's coming out of the exhaust? Well, we've got HC, we've got our hydrocarbons, carbon monoxide, oxygen, some oxides of nitrogen, and some CO2. So some of these gases are harmful and some are not. If you're looking at the slide, you can see where my lowest levels are hydrocarbon and CO if everything's worked well. I've also got a low level of oxygen. Now I've got higher levels of oxides of nitrogen and CO2. All right, so we're going to take a look at what the cat does and how it makes the change from what we have coming in to what we have coming out. Next screen. There we go. So I know a lot of you guys, especially you Virginians, a lot of you guys have told me, hey, I do emissions work. So you're familiar with this. If you look at the chart, that big thick black line in the center, that's stoichiometry, or what we talk about as being a balanced mixture. Now, with it being a balanced mixture, what are we talking about? It's really the best possible outcome that we can get with what we have. So is it going to make the most power? No, it needs to be more rich if we want to make more power, or have more hydrocarbon. If we want to get better mileage, we need it to be leaner. Now, look at the line for NOx. It kind of looks like a mountain right there in the center. There you go, Scott. Thank you. NOx is really our big compromise here. Notice it's stoichiometric or balanced. My hydrocarbons and my CO are low, but NOx is relatively high. If we were to add more fuel and have a richer mixture, my NOx would go down. But what suffers? My hydrocarbons. So you can see where this is really a kind of a tough balancing act. All right, next screen, Scott. All right, so we're going to use a catalyst to assist in cleaning this up. So what is a catalyst? Somebody give me a definition. What is a catalyst? We talk about it in a lot of different things, not just in cars. We're going to play for a prize of unspeakable value. Who can tell me what a cat is?
Burns the unburned hydrocarbons.
Yeah, that's one thing it does. It does help to get rid of the unburned hydrocarbons, you're right. But what I'm looking for here, guys, is that next screen, Scott, a catalyst is something that affects change without itself being changed. The catalytic converter really helps to change around the mixture of the different molecules that are in the intake and the exhaust, all right, in the exhaust gas. All right, so next screen, please. So what does an automotive catalyst change? Click it again, Scott. It's going to change the 3 really hazardous or harmful gases here. All right, so we're really looking at it to help us with hydrocarbons, CO, which is a poisonous gas, and oxides of nitrogen. All right, next screen. So with our cats, the cats do 2 different things for us. On one part of the cat called reduction, it's going to help to get rid of the excess oxides of nitrogen. All right, so to do that, it's going to use a precious metal. It's called rhodium. It's going to use some platinum and a rhodium to help remove NOx. Now, there's also another portion of this called oxidation, and the oxidation is what's going to help get rid of the hydrocarbons, right? So the HC and the CO. And the 2 metals that we're going to use to get rid of those or help clean those up are platinum and palladium. again, for a prize of unspeakable value, of the rhodium, the platinum, and the palladium that are in the cat, what do you think is the most expensive in terms of what it would cost per gram? Kurt, you can't answer. Put your hand down. What'd you say, John?
Palladium.
All right, palladium. All right, so you're absolutely correct, and that's why when the cost of palladium goes up, cats get stolen at a higher rate, especially from Free Eye. So here's your gift. I'm going to give you a free lunch. All right, so next time you come out, just see me, and I'll be sure to give you your coupon. Next screen, Scott. All right, so this is the Chris Peterson check engine light. He always said when it comes on, it's going to cost you something. So what stops, when we get a check engine light on and we have a cat failure, what's the problem? Well, the problem is that the exhaust gas can no longer intermingle and be changed by the metals inside of the cat. So what are some things that can cause failures? David, what can cause a cat failure? Dave, you're muted.
Too much fuel, misfires.
Yeah, Scott talked about that the other day, didn't he? Yeah, he had that with the catalyst over temperature, malfunction, cutoff. And a lot of letters in an acronym there. So yeah, when that happens, that's definitely one of the things that can cause trouble. It can help if the cat can overheat and become damaged. If it gets knocked by a cinder block, I'm driving on Route 10 and one falls off the truck in front of me and bangs my cat, that can screw it up. Scott, can I get the next screen? But another thing that can damage the cat is something that might be coolant, maybe some 5G. The car is burning oil. A customer fills up by mistake with a tank load of diesel fuel. Right, it's got a lot of sulfur and crap in there, so that can cause some problems also. All right, next screen, please. So testing or checking a catalytic converter is really about checking it for its ability to store oxygen. So let's go to the next screen and I'll tell you why that is. So I mentioned that inside of a cat, we've got a couple of different metals. We've got rhodium that helps with NOx. We've got the palladium that helps us out with the hydrocarbons and CO. There's another very important metal called cerium. And the purpose of that metal is to help to absorb oxygen and to release oxygen. So when the catalytic converter is functioning and we're trying to get rid of NOx, it has to happen in an environment where we have very little oxygen. Now, just the opposite's true. We're trying to get rid of the hydrocarbons. We have to have oxygen available to make that work. So if you're looking at this screen, up at the top here on the top diagram, there's a lean mixture. Well, why is it lean? Because what's inside of that cat, all those black dots, is indicating a lack of oxygen that's available. Now, as the car's being driven down the road, it's going to go rich lean, rich lean, rich lean. Sometimes it needs more oxygen, sometimes it doesn't. In this case, it does. So the engine or the ECU is going to cause a lean condition, and it's going to start filling back up. That cerium is going to start absorbing oxygen inside. Scott, that's awesome with the pointer. Thank you so much. Now, when the cerium is reached its maximum capacity, the ECM is watching the AF or the upstream sensor and the downstream sensor. It sees that it's changed, and now it goes back to the regular mixture, no longer a little bit lean. While this is happening, customer never notices. It happens just like that. All right, next screen, please. So if I'm out there on Route 10, and I'm cruising along at 60 miles an hour or whatever. Scott, can I get that next screen, please? Uh-oh. There we go. So now I'm on Route 10, and I want to pass this truck that's dropping these cinder blocks in front of me. So I step on the gas. I got a really rich mixture now, right? So I don't have much oxygen. Remember, anytime I'm rich, the fuel is going to mix with all the oxygen it can get its hands on, so I can have combustion. When this happens, we're not going to have enough oxygen available to make to help the HCs or the hydrocarbons transfer or change in the cat. Some of those are going to become diminished. So that's why the cat has to be able to store oxygen inside. And if you look at the one on the bottom, yeah, that one now is completely depleted. and the cycle will start over again. I'll go back to the first one. All right, next slide, please, Scott. All right, so we need to talk about monitors. So what is a monitor? What do you guys consider a monitor?
It's like a self-test.
Yeah, it's a self-test of either a system or a group of components, or maybe even a single component, all right? Go ahead and flip it again, Scott. So what is it looking for during this test? Well, it's watching to see whether or not the emissions exceed 1.5 times the permissible amount. So next screen, please. What is permissible? Whatever the car was built for at when it was manufactured, whether it was ULEV or ultra ULEV or AT-LEV, partial zero. All these are different configurations. So however the car was originally certified, that's where it's looking for that upper limit of 1.5 versus the original certification. All right, next screen, please. So on the monitor screen, I don't know how many of you guys have ever really noticed this, but there's a ton of information here. And I know Scott touched on some of this yesterday. So current monitor. Current monitor is simply the trip that you're on right now. All right. Next click. There's also a cumulative monitor. So if current monitor is what's happening now, cumulative reasonably is what happened the last time the monitor ran. Now there's a bit of a caveat to this. If you get into a car and you hit the ignition and you don't start it, but you turn the ignition on, if you look at the current monitor, it's going to show you the results from the last time the car ran, last time the monitor ran. If you hit the start button, you start it up, it's a new day, a new trip. Now that current monitor is going to reflect what's happening right now. So that could be useful to you guys when you're checking to see whether or not a monitor ran or what the test looked like when you tried to check to see if that cat's working or not. All right, again, please, Scott, you can go ahead and click it 2 more times now. So there are 3 different monitors here. One more, please. 3 different monitors that are closely related. There's the O2 heater, there's the O2 sensor, and there's the cat monitor itself. Today we're really looking just at the cat monitor. I guess Kurt's going to look at the other 2 when he does his bit next week. So looking across the screen, you guys can see where it shows for the cat monitor. It's ready. It's incomplete, meaning it hasn't run right now. It says pass. Pass is the default. Unless it actually fails, it's going to give you pass. And you can see where it hasn't run. Again, there you go, Scott. You got the big question mark all the way to the right. Now, you've got the detail screen. So, Scott, if you click that again, the details or the magnifying glass, thank you, that's perfect. That's going to show you what is happening within the test. Now, you can see where this test is for the O2 sensor. The O2 sensor, I've got about 10 different tests here on the screen, and there are probably another 10. I can see the slide bar has a lot more to offer. Here's the deal with this. Hit it again, Scott. So the highlighted area that says max volume, bank 2, sensor 2. You can see where the test result is fail. And it's populated showing me what my minimum threshold is, my maximum amount, and then what I actually achieved, my test value, and in volts. So because the test value was outside of the range, it failed. So what that means is, yep, that's right, the whole test failed. And we can't do partial complete here and yada, yada, yada. Scott, click it again. You'll notice that below that, there's part of the test that shows pass. But I've got zeros across the bar. What that means is it never got to that part of the test. And again, when it says pass, that's the default. Unless it actually fails, it's going to say pass. All right, next screen. So this screen is actually from a 2020 Highlander, and this is your cat efficiency monitor. Looking at the details, you can see where, Scott, if you click it, the oxygen storage, pretty short, simple test. I've only got 2 items. Because it's a 2GR, I've got 2 banks, so it's showing me bank 1 and bank 2 oxygen storage capacity. So looking across here, it's showing you pass, and I've got my min and my max and my test value. The test value is inside of my min and my max. What you have to be careful of here, guys, is not to get hung up on that minimum value. Scott, click it again. If you went to the repair manual for this vehicle and you looked at the oxygen storage capacity of the CAT for North American vehicle, which this is, it shows you a value of less than 1. Well, my screen agrees with that on my minimum, right? I see the same thing there, but look below it for a Mexican vehicle. Yeah, it's about 80% less. The standard's much lower. And I looked up a standard for a 2010 Highlander with the 1AR 4-cylinder engine. That one was about 50% less. That was like around 0.08 of grams of storage capacity for oxygen. So different cars, different certification levels are going to have different thresholds. All right, Scott, let's go. So what's going on here when we run the test? Well, you guys have probably seen this 100 times before. If I have a normal catalyst and the ECM is commanding rich lean, rich lean, rich lean, or if it's simply going that way, just reporting on how well the fuel injection is doing, I can see where my AF sensor agrees and it's going up and down. All right, so I'm going rich, lean, yada, yada, yada. My sub O2 or my sub AF has got a nice straight pattern here. This is telling us that the oxygen storage capability inside is actually working properly. If you look at the one on the right, where the sub sensor is moving up and down, it doesn't have enough oxygen to be able to counteract the hydrocarbons inside. So we've got an issue there with that CAT. All right, next screen, please. So when the ECM sees that the conditions are favorable for running this test, it goes into what it's called an active air fuel control test. And you can see this as a parameter on TechStream. So as the fuel injection volume is increased and decreased, right? Up is increased in this case, down is decreased. You can see where below that the AF sensor is corresponding in kind. If it's running slower, it's going to be judged. There's going to be a judgment made about the performance of that sensor, and you're going to get a performance or range code sensor code. Look down below that to the sub sensor. Normally the sub sensor is pretty smooth, right? You see that nice solid line, that looks good. If it's up and down and all over the place, okay, so we're not storing oxygen, we're not reacting with the hydrocarbon. All right, so we've got a malfunction. Next screen, please. So I mentioned that with the active air fuel ratio control, this is for all of our later model cars. If you're working on something that was built before the turn of the century, guys, it's going to be different. It doesn't do this automatically. It can't be, it's non-intrusive. It would have to, the vehicle would be much more difficult to get to run this test because all the conditions and the stars have to align before the test can be run. In this case, our newer stuff, once the basic conditions are good, the computer will go ahead and start this test. Doesn't take that long to run either. Maybe 10 or 20 seconds and the whole test is over with. Customer doesn't feel it. They don't recognize the thing going on here. All right, next screen, please, Scott. All right, so can you guys see on this screen, can you identify where you think that the active test is actually taking place? It's kind of hard to see. And looking at the screen, just kind of going from the bottom up, the bottom one is my sub O2. The next screen up is my AF sensor. The next screen up here is my air fuel ratio. And next screen up from that one's going to be my throttle position. Anybody want to hazard a guess here at about what second mark the test might be occurring? Yeah, I know it might be kind of hard to see on this screen. Scott, hit the next slide, please. Let's blow it up a little bit. Yeah, so it's that place all the way down toward the end here. Looking at the screen, yep, Scott's circling that squiggle. That's where it's increasing and decreasing fuel. So you might need to be careful of this if you got a drivability problem and you see something like this. This is not your drivability problem, all right? This is going to be undetected. So looking at this, we can see that the fuel is being increased, decreased. Below that, the next line down, AF sensor, it's corresponding, and then my CAT or my O2 sensor on the very bottom, it's pretty smooth here. Now, the system's going to take some wide swings and hold this lean and hold it rich for a period of time. So Scott, if you, there you go, over in that section. And at this point, it's really looking to see how long or how much oxygen that cat could store. And then the very final portion here, might be easier if you click it again, Scott. Yeah, very final portion, that's where it's making the judgment on the catalyst and the oxygen storage capability of that unit. All right. So this is how that works. All right, one more screen. Yeah, so this is a good example of a failed cat. You can see where the engine ECM was commanding the rich lean, and the AF looks okay, it's corresponding. But look what's going on with that sub AF or the O2. Yeah, in this case, it's an O2. I can tell that down there by the voltage. Yeah, it's all over the place. So it's not storing any oxygen. It's not making a difference. All right, and down on the very bottom part here where it says, Scott, go back one more screen. On the very bottom, yeah, we've got catalyst monitor complete. It's running, but it's incomplete at that point. And then at some point, it's going to drop down and show you that it was complete when the test actually ends. I think we can see that on the next screen, please. Yeah, so this one, yep, so the catalyst monitor result is in gold. There you go. You can see where it was on and then it turned off. And you can see where the green line is the upstream AF. The red line is the downstream AF. And notice I said AF on this one. The lines look like they're pretty close together. All right, now in reality, they wouldn't be that way because we're now measuring in milliamps on those AFs, and they're going to be, the sub AF will be about 8 to 10 times larger in milliamps than the upstream AF will be. All right, next screen.